George Gamow was a pioneering theoretical physicist and cosmologist whose work transformed how scientists understand the universe. To understand why he is considered a pioneering figure, it is important to look at what he studied, how he approached science, and why his ideas were revolutionary for his time. George Gamow was born in 1904 years. Gamow was born in 1904 years in Odessa, a city that was part of the Russian Empire, now in Ukraine. From a young age, he showed an extraordinary interest in science, especially physics and mathematics. As a student, he was fascinated by the mysteries of the universe, questions such as how the universe began, how stars produce energy, and how matter is formed. These questions were not easy to answer. And during Gamow's early years, many scientists had only limited theories and experimental evidence to explain them. Gamow became a theoretical physicist, which means he focused on developing mathematical models and theories to explain how the universe works. Unlike experimental physicists who perform experiments in laboratories, theoretical physicists use mathematics and logical reasoning to predict how nature behaves. Gamow was especially skilled in using mathematics to explain complex physical processes in a way that other scientists could test and build upon. One of the reasons Gamow is considered a pioneer is that he worked in multiple areas of physics and made important contributions to each of them. He worked on quantum mechanics, nuclear physics, cosmology, and astrophysics. At a time when many scientists specialized in only one field, Gamow's ability to connect ideas across different areas of science was unusual and powerful. Gamow made early contributions to quantum tunneling, a phenomenon in quantum mechanics where particles can pass through barriers that would be impossible according to classical physics. His work helped explain radioactive decay, showing how particles escape from atomic nuclei. This was a major step in understanding nuclear reactions and atomic behavior. However, Gamow is best known for his work in cosmology, the study of the universe as a whole. During the early 20th century, cosmology was still a developing science. Scientists were debating whether the universe had a beginning or whether it had existed forever. When the Big Bang theory was proposed, many scientists were skeptical. Gamow became one of the strongest supporters and developers of the Big Bang theory. He believed that the universe began in a very hot and dense state and expanded over time. Gamow used physics and mathematics to explain what happened in the first moments after the Big Bang. His theories helped explain how the first elements were created and why the universe looks the way it does today. Because of his work, cosmology changed from a philosophical topic into a scientific field with testable predictions. Gamow also worked with other famous scientists, such as Ralph Alpher and Robert Herman. Together, they predicted the existence of cosmic microwave background radiation, which is leftover heat from the Big Bang. Although this radiation was not discovered until years later, its discovery provided strong evidence that the Big Bang theory was correct. This prediction is one of the greatest achievements in modern science, and Gamow played a key role in it. Another reason Gamow is called a pioneer is his ability to explain complex scientific ideas in simple and engaging ways. He believed that science should not be limited to experts, but should be shared with the public. He wrote popular science books that explain topics like atoms, stars, and the universe in a humorous and easy to understand style. His books inspired many young students to pursue careers in science. Gamow's personality also made him unique. He was known for his creativity, humor, and curiosity. He did not hesitate to challenge existing ideas and propose bold theories. This fearless approach is what often leads to major scientific breakthroughs. Gamow's willingness to explore new ideas helped push physics and cosmology forward during a critical period in scientific history. George Gamow is called a pioneering theoretical physicist and cosmologist because he made groundbreaking contributions to several areas of physics, helped develop the Big Bang theory, explained how the elements were formed, predicted important cosmic phenomena, and inspired others through his writings. His work laid the foundation for much of modern astrophysics and cosmology, and his influence continues to shape how scientists study the universe today. George Gamow's role as a pioneering theoretical physicist and cosmologist becomes even clearer when we examine the scientific environment in which he worked. During the early 1990s, physics was undergoing a revolution. Classical physics, which had dominated science for centuries, was being replaced by new theories such as quantum mechanics and relativity. Many scientists were confused by these new ideas, but Gamow quickly embraced them and contributed to their development. I belong to a generation of physicists who reshaped humanity's understanding of nature at the most fundamental level. Gamow studied at the University of Leningrad, where he was influenced by leading physicists of his time. He later traveled to Western Europe, where he worked with famous scientists such as Niels Bohr and Paul Dirac. These experiences exposed him to the most advanced ideas in modern physics. Gamow's intelligence and creativity allowed him to contribute original ideas rather than simply learning from others. His early work on nuclear physics gained international recognition, and he quickly became known as a rising star in theoretical physics. In 1930, Deleta Barloea Benefer desais dea Benefer Ping. Deleta Barloea Mao Benefer to the United States, where he continued his research and teaching career. He became a professor at George Washington University, where he influenced many students who later became important scientists. In the United States, Gamow found a supportive environment for his research, and he was able to freely explore his ideas about the universe. This period was crucial for his work in cosmology and nucleosynthesis. One of Gamow's pioneering achievements was connecting nuclear physics with cosmology. Before Gamow, many scientists studied atoms and nuclei in laboratories, while others studied galaxies and stars in the sky. Gamow realized that these two fields were connected. He believed that the laws governing tiny atomic particles also control the behavior of the tiny atomic particles. Bold, the basing obvious today, but at that time it was Gamow used nuclear physics to explain what happened in the early universe. He proposed that the universe started as an extremely hot and dense primal fireball. In this early stage, nuclear reactions occurred everywhere, producing the first atomic nuclei. This theory explained why the universe is mostly made of hydrogen and helium. His work provided a scientific explanation for the chemical composition of the universe, something that had never been clearly understood before. Gamow also emphasized the importance of evidence and predictions in science. And his colleagues predicted the existence of cosmic background radiation long before it was discovered. When scientists later detected this radiation in 1965, it confirmed many of Gamow's ideas and strengthened the Big Bang theory. This ability to make predictions that could be tested is a key reason why Gamow is considered a pioneer. He helped transform cosmology from speculation into a scientific discipline. Another important aspect of Gamow's pioneering role was his influence on future research. His theories inspired generations of physicists and astronomers to study the early universe, nuclear reactions in stars, and the origin of elements. Modern fields such as astrophysics, particle cosmology, and nuclear astrophysics are built on ideas that Gamow helped develop. Many modern scientific discoveries, including detailed measurements of cosmic background, radiation, and studies of element formation, trace their roots back to his work. Gamow also contributed to biology in an unusual way for a physicist. Later in his career, he became interested in the genetic code and how information is stored in DNA. He proposed early ideas about how genetic information could be encoded, showing that his curiosity extended beyond physics. This interdisciplinary thinking further demonstrates his pioneering spirit, as he was willing to explore new scientific frontiers. Beyond this scientific research, Gamow's role as an educator and science communicator was groundbreaking. He believed that science should be shared with the public, not hidden in academic journals. His popular books, such as 1, 2, 3, Infinity and Mr. 2, MPkin series explain complex topics like relativity and quantum mechanics through stories and humor. These books made science accessible and exciting, and they inspired countless readers around the world. Gamow's teaching style was also innovative. He encouraged students to think creatively and question established ideas. He believed that curiosity and imagination were essential for scientific progress. Many of his students remembered him as an inspiring teacher who made difficult concepts easy to understand. His influence as a mentor helped shape the next generation of scientists. His personality played a major role in his pioneering success. Gamow was known for his sense of humor, creativity, and fearless approach to science. He was not afraid to challenge famous scientists or propose unconventional ideas. This courage is often what separates pioneers from ordinary researchers. Gamow understood that science advances through bold ideas, even if some of them turn out to be wrong. Gamow's legacy is still visible today. Modern cosmology, nuclear physics, and astrophysics rely on theories and methods that he helped establish. His work on the Big Bang, nucleosynthesis, and cosmic radiation remains fundamental in textbooks and research. Scientists continue to refine his theories with new data, but the basic framework he helped build is still used. George Gamow made major contributions to understanding how elements formed in the universe, and this achievement is one of the most important milestones in modern science. Before his work, scientists knew that the universe contained many different elements, such as hydrogen, helium, carbon, oxygen, and iron, but they did not clearly understand where these elements came from or how they were created. Gamow helped solve this mystery by connecting nuclear physics with cosmology and astrophysics, creating a scientific explanation for the origin of matter. To understand the importance of his contribution, we must first understand what elements are. Elements are basic substances made of atoms, and each element has a unique type of atom with a specific number of protons in its nucleus. For example, hydrogen has 1 proton, helium has 2, and carbon has 6. These elements combine to form everything in the universe, including stars, planets, water, air, and living organisms. For many years, scientists wondered how these elements were formed in the first place. Before Gamow, there were different theories about the origin of elements. Some scientists believed that all elements existed forever, while others thought they were created inside stars. However, no one had a complete explanation for how the first elements appeared or why some elements are more common than others in the universe. Gamow changed this by proposing that the universe itself created elements during its earliest moments. Gamow believed that the universe began in a very hot and dense state which is now known as the Big Bang. In this early stage, the temperature was extremely high and matter was compressed into a tiny space. Under these conditions, nuclear reactions could happen everywhere in the universe. Gamow proposed that during the first few minutes after the universe began, protons and neutrons combined to form the first atomic nuclei. This process is called nucleosynthesis, meaning the creation of new nuclei. Gamow used mathematics and physics to calculate how these reactions would occur. He worked with his student Ralph Alpher and colleague Robert Ehrman to develop detailed models of how hydrogen and helium were formed. Their calculations showed that most of the universe should be made of hydrogen, with a smaller amount of helium and traces of other light elements, like lithium. This prediction matched what astronomers later observed, proving that Gamow's theory was highly accurate. One of the most significant contributions Gamow made was explaining why hydrogen and helium are the most abundant elements in the universe. Today, scientists know that about 75% of the universe visible matter is hydrogen and about 25% is helium. Gamow's theory explained this ratio as a natural result of the conditions in the early universe. His work provided a scientific answer to a question that had puzzled scientists for centuries. Gamow also helped scientists understand that heavier elements, such as carbon, oxygen, and iron, were not created during the Big Bang but inside stars. He suggested that stars act like giant nuclear reactors, where lighter elements fuse together to form heavier ones. This idea was later developed further by other scientists, but Gamow's early insights were crucial in establishing the connection between stars and the creation of elements. Another important part of Gamow's contribution was his use of scientific prediction. He did not just describe what might have happened. He made precise predictions that could be tested by observations. For example, his models predicted the amount of helium in the universe and the existence of leftover radiation from the Big Bang. When scientists later confirmed these predictions, it strengthened the scientific credibility of his ideas. Gamow's work also influenced many other scientists to study the origin of elements in more detail. His theories opened a new field called nuclear astrophysics, which studies how nuclear reactions occur in stars and in the early universe. Today, scientists use powerful telescopes and particle accelerators to study nucleosynthesis, but the basic framework they use was first developed by Gamow and his colleagues. In addition to his scientific research, Gamow helped explain these complex ideas in a way that students and the public could understand. I believe that understanding the origin of elements was important not only for scientists but for everyone, because it explains where we come from and what the universe is made of. His popular books and lectures made the topic of element formation fascinating and accessible to non-scientists. Gamow's contribution to understanding how elements formed in the universe changed science forever. He provided a clear scientific explanation for the chemical composition of the universe, connected the birth of the universe with the atoms in our bodies, and inspired future research in cosmology and astrophysics. His work showed that the story of the universe is written in the elements themselves, and by studying them we can learn about the earliest moments of existence. George Gamow's contribution to understanding how elements formed in the universe did not stop at proposing ideas. It reshaped how scientists viewed the relationship between time, matter, and cosmic evolution. His work helped establish the idea that the universe has a chemical history, meaning that the elements we see today were created through specific physical processes over billions of years. This concept was revolutionary because it suggested that the universe evolves not only in size and structure, but also in composition. One of the most important aspects of Gamow's work was showing that the formation of elements followed clear physical laws. He demonstrated that the types of elements created depended on temperature, density, and time. In the early universe, conditions were extreme, with temperatures so high that atoms could not exist. As the universe expanded and cooled, conditions became suitable for nuclear reactions to occur. Gamow showed that there was only a short window of time during which these reactions could take place. Once the universe cooled too much, element formation slowed dramatically. This explained why only light elements were created in the earliest moments. Gamow's calculations revealed that the universe cooled too quickly for heavy elements to form during its beginning. This insight helped solve a long-standing mystery: why elements like gold, iron, and uranium are relatively rare compared to hydrogen and helium. Gamow explained that these heavier elements require long-lasting environments with stable conditions, which could only exist inside stars. This understanding connected cosmic history with stellar life cycles and showed that stars play a crucial role in shaping the material universe. Another major contribution of Gamow's work was its impact on observational astronomy. His theories gave astronomers clear expectations about what they should observe when studying stars, galaxies, and interstellar space. For example, astronomers could measure the abundance of elements in stars and compare them with Gamow's predictions. When observations matched theoretical expectations, it confirmed that the theory of element formation was correct. This close relationship between theory and observation strengthened the scientific foundation of cosmology. Gamow's ideas also influenced how scientists interpret cosmic radiation and light from distant objects. Because light carries information about the AC. Elements present in stars and galaxies, astronomers use spectroscopy to identify chemical compositions. Gamow's framework helped scientists understand why distant galaxies, which formed early in the universe, contain mostly light elements. This observation supports the idea that heavier elements were created later over long periods of stellar evolution. His work also had philosophical implications. By explaining how elements form naturally through physical laws, Gamow helped move science away from mystical or speculative explanations of matter's origin. It showed that the universe follows understandable principles, and that even the most fundamental components of reality have a traceable history. This reinforced the idea that science can answer deep questions about existence through observation, logic, and mathematics. Gamow's influence extended beyond his own lifetime. Many scientists built upon his ideas to develop more detailed models of element formation. Later research explained how supernova explosions create the heaviest elements and scatter them across space. These discoveries expanded the Gamow's original framework and showed that the universe recycles matter through cosmic events. Planets, stars, and living beings are made from material created in ancient stars, an idea rooted in Gamow's early insights. His work also helped unify different scientific disciplines. Chemistry, physics, astronomy, and cosmology all intersect in the study of element formation. Gamow showed that understanding the universe requires collaboration across fields. This interdisciplinary approach is now standard in modern science, but during Gamow's time, it was innovative and bold. Gamow's role as a teacher and mentor further amplified this impact. It trained students to think broadly and dice lo siguiente, them to see connections between seemingly unrelated phenomena. Many of his students went on to make important discoveries of their own, spreading his influence across generations of their own. Spreading his influence across generations. Through teaching, Gamow ensured that his ideas would continue to shape scientific thinking long after his own research ended. In addition to formal education, Gamow reached a wide audience through popular science writing. He explained the origin of elements using simple language, vivid analogies, and humor. By doing so, he helped the public understand that the atoms in their bodies were forged through cosmic processes This idea deeply changed how people viewed their place in the universe, creating a sense of connection between humanity and the cosmos. Gamow's explanations also help inspire curiosity and wonder. Learning that the elements around us were created in the early universe and inside stars encourages people to see science as a story of transformation and continuity. Gamow understood that science is not only about equations and data, but also about meaning and perspective. His ability to convey this made his work especially powerful. Today, advanced technology allows scientists to study element formation with incredible precision. Satellites measure cosmic radiation, telescopes observe distant galaxies, and particle accelerators recreate high energy conditions similar to those in the early universe. All of these modern achievements rely on the foundational ideas Gamow introduced. His work provided the roadmap that guides current research. In the broader context of human knowledge, Gamow's contribution stands as a reminder that understanding the universe begins with asking fundamental questions. Where did matter come from? Why are certain elements common while others are rare? Gamow helped answer these questions by showing that the universe has a logical, measurable history. His work transformed abstract questions into scientific investigations. George Gamow helped explain nucleosynthesis, the process by which atomic nuclei are formed, and this was one of his most important contributions to modern science. Nucleosynthesis is a scientific process that creates the building blocks of all matter in the universe. Every element from hydrogen in water to iron in blood and gold in jewelry exists because of nucleosynthesis. Before Gamow's work, scientists did not clearly understand how these atomic nuclei were created. Especially in the early universe, Gamow proposed that nucleosynthesis began shortly after the universe was born in the Big Bang. At that time, the universe was extremely hot and dense, with temperatures so high that matter existed as free particles such as protons and neutrons. As the universe expanded and cooled, these particles began to combine through nuclear reactions. Gamow explained that during the first few minutes after the Big Bang, protons and neutrons fused together to form the nuclei of light elements, mainly hydrogen and helium. This process is called primordial nucleosynthesis. Using mathematics and physics, Gamow and his colleagues calculated how much of each element should be produced. Their models predicted that most of the universe should consist of hydrogen with a smaller amount of helium and traces of other light elements like lithium. Later observations confirmed these predictions, making Gamow's theory a strong pillar of the Big Bang model. His work explained why hydrogen and helium are the most abundant elements in the universe. Today, Gamow also helps scientists understand that heavy air elements such as carbon, oxygen, and the iron were formed later inside stars. Inside stars, nuclear fusion occurs where lighter nuclei combine under extreme heat and pressure to form heavier nuclei. This stellar nucleosynthesis continues for billions of years and creates the elements that make up planets and living organisms. Gamow's ideas connected the early universe with the life cycle of stars, showing that the universe is constantly creating new matter. Another major contribution of Gamow's work was predicting cosmic background radiation, leftover heat from the Big Bang. This radiation is evidence that the universe was once extremely hot and supports the theory of primordial nucleosynthesis. When scientists discovered this radiation in 1965, it confirmed many of Gamow's ideas about the early universe. In simple words, Gamow helped explain where the atoms in everything around us come from. His work showed that the universe itself is a giant laboratory where atomic nuclei are created through natural processes. By explaining nucleosynthesis, Gamow gave humanity a scientific story of how matter was formed, linking the birth of the universe to the existence of stars, planets, and life. George Gamow proposed important ideas about the Big Bang and the early universe, and his work helped shape modern cosmology. The Big Bang Theory is the scientific explanation that the universe began from an extremely hot and dense state and has been expanding ever since. Before Gamow, many scientists were unsure whether the universe had a beginning or if it had always existed. Gamow played a key role in developing and supporting the idea that the universe had a definite starting point. Gamow believed that the universe began as a tiny, incredibly hot primeval fireball. In this early stage, all matter and energy were packed into a very small space. According to his theory, the universe then began to expand rapidly. As it expanded, it cooled down, allowing particles to form atoms, stars, and galaxies. This idea helped scientists understand how the universe evolved from a simple hot beginning into the complex structure we see today. One of Gamow's major contributions was explaining what happened in the first few minutes after the Big Bang. It suggested that during this time, nuclear reactions occurred throughout the universe, creating the first atomic nuclei. This process explained the origin of light elements such as hydrogen and helium. His work connected the Big Bang theory with nucleosynthesis, showing that the early universe acted like a giant nuclear reactor. Gamow also predicted that the early universe would leave behind a faint glow of radiation as it cooled. This radiation, now known as cosmic microwave background radiation, is the leftover heat from the Big Bang. Although Gamow could not detect it himself, he and his colleagues calculated that it should still exist in space. In 1565, scientists discovered this radiation, providing strong evidence that the Big Bang theory was correct. This discovery made Gamow's ideas even more important in modern science. Another important part of Gamow's work was his use of mathematics and physics to make testable predictions. He did not just describe the Big Bang in words. He used discernment to explain how the universe expanded, cooled, and formed matter. This scientific approach helped transform cosmology from a philosophical topic into a precisely scientific field. Gamow's ideas also influenced future research. Scientists use his theories to study the age of the universe, the formation of galaxies, and the evolution of cosmic structures. His work inspired many cosmologists to explore the earliest moments of the universe using telescopes and satellites. In conclusion, George Gamow proposed groundbreaking ideas about the Big Bang and the early universe. He explained how the universe began, how it cooled and expanded, how matter formed, and how evidence of the Big Bang still exists today. His contributions help scientists understand the origin of the universe and laid the foundation for modern cosmology. George Gamow worked with other scientists to develop the theory of stellar and primordial nucleosynthesis, which explains how elements are formed both in the early universe and inside stars. His collaboration with other researchers was crucial because the origin of elements is a complex topic that requires knowledge from physics, astronomy, and mathematics. By working with colleagues, Gamow helped build a complete scientific picture of how matter in the universe came into existence. One of Gamow's most important collaborations was with his student Ralph Alpher and physicist Robert Herman. Together, they studied what happened in the universe just after the Big Bang. They developed detailed mathematical models to describe how protons and neutrons combine to form the first atomic nuclei. This process is called primordial nucleosynthesis, meaning the creation of elements in the earliest moments of the universe. Their work showed that hydrogen and helium were formed first with small amounts of other light elements like lithium. Gamow and his colleagues calculated the exact conditions needed for these nuclear reactions, such as temperature, density, and time. They showed that the universe cooled very quickly, so only light elements could form during This early period. This explained why hydrogen and helium are the most abundant elements in the universe today. Their predictions matched astronomical observations, which made their theory widely accepted by the scientific community. In addition to primordial nucleosynthesis, Gamow also contributed to the understanding of stellar nucleosynthesis, the process by which stars create heavier elements. He suggested that stars act like nuclear factories where lighter elements fuse together under extreme heat and pressure. For example, hydrogen nuclei combine to form helium, and helium can later form carbon and other heavier elements. This process continues in stars for millions or billions of years, gradually building the elements needed for planets and life. Gamow's ideas about stellar nucleosynthesis inspired other scientists to study how stars produce elements. Later researchers, such as Fred Hoylen and others, expanded on these ideas and explained how very heavy elements like gold and uranium are formed in supernova explosions and other cosmic events. Gamow's early work provided the foundation for these later discoveries. Another important result of Gamow's collaboration was the prediction of cosmic background radiation. Gamow, Alpher, and Hermann suggested that if the universe began hot and dense, some radiation should still exist as a faint background glow. Decades later, this radiation was discovered, providing strong evidence for the Big Bang and primordial nucleosynthesis theories. Gamow's teamwork with other scientists shows the importance of collaboration in science. By sharing ideas, testing theories, and combining knowledge from different fields, they were able to solve one of the greatest mysteries in science: where the elements come from. In conclusion, George Gamow's work with other scientists led to the development of the theories of stellar and primordial nucleosynthesis. Their research explained how the first elements formed after the Big Bang and how stars continued to create heavier elements. This collaboration transformed our understanding of the universe and the origin of matter, making it one of the most important achievements in modern physics and cosmology. George Gamow was also known for explaining complex science in simple and engaging ways, which made him not only a great scientist, but also an exceptional science communicator. Many brilliant scientists focus only on research and technical papers, but Gamow believed that scientific knowledge should be shared with everyone. He thought that understanding the universe should not be limited to experts in laboratories and universities, but should also be accessible to students, teachers, and the general public. Gamow had a rare talent for turning difficult scientific ideas into clear and interesting stories. Topics like quantum mechanics, relativity, cosmology, and nuclear physics are usually full of complicated mathematics and abstract concepts. However, Gamow used simple language, humor, and everyday examples to make these topics easy to understand. He believed that curiosity is natural in humans and that people enjoy learning when ideas are presented in an entertaining way. One of his most famous contributions to science communication was his popular science books. His book 1, 2, 3, Infinity explained complex topics such as space, time, atoms, and the universe in a way that ordinary readers could enjoy. Instead of using technical terms, he used analogies and illustrations to help readers imagine scientific concepts. This book inspired many young readers to become interested in physics and astronomy. Gamow also wrote the Mr. Tompkins series, which used fictional stories to explain scientific theories. In these stories, the main character, Mr. Tompkins, experiences strange dreams where the laws of physics are different. Through these dreams, Gamow explained relativity, quantum mechanics, and cosmology in a creative and entertaining way. This storytelling method made learning science fun and memorable. In addition to writing books, Gamow was a great teacher and lecturer. His lectures were famous for being lively, humorous, and easy to follow. He encouraged students to ask questions and think creatively. Instead of making science feel difficult and boring, he made it exciting and inspiring. Many of his students later became successful scientists and credited Gamow for motivating them. Gamow also believed that humor could be a powerful teaching tool. He often included jokes, cartoons, and funny examples in funny examples in his explanations. This helped people relax and understand difficult topics without feeling overwhelmed. His friendly and enthusiastic style made people feel that science was not something to fear, but something to explore, Another reason Gamow was effective at explaining science was his ability to connect scientific ideas with everyday life. Explained how atoms form everything around us, how stars produces the elements in our bodies, and how the universe evolved over time. By connecting science to real-world experiences, it helped people see the importance of physics and cosmology in their daily lives. Gamow's work in science communication had a lasting impact. Many modern science writers and educators follow his style of using simple language, stories, and humor to explain complex ideas. He helped create a tragedy on of popular science writing that continues today. In conclusion, George Gamow was not only a brilliant physicist but also a gifted communicator. His ability to explain complex science in simple and engaging ways helped inspire generations of students and readers. By making science accessible and enjoyable, he played a major role in spreading scientific knowledge and encouraging curiosity about the universe. George Gamow's work had a powerful influence on modern cosmology, astrophysics, and our understanding of the universe origin. It was one of the key scientists who helped turn the study of the universe into a precise and established science. Before his contributions, many ideas about the universe were philosophical or speculative, but Gamow used mathematics and physics to create scientific explanations that could be tested through observation. In cosmology, Gamow played a major role in developing the Big Bang theory. He believed that the universe began in a very hot and dense state and has been expanding ever since. He studied what happened in the earliest moments after this beginning and explained how matter and energy evolved as the universe cooled. His work helped scientists understand the early stages of cosmic history and provided a scientific model for how the universe changed over time. Gamow also helped explain nucleosynthesis, the process that creates atomic nuclei. It showed that during the first few minutes after the universe began, nuclear reactions produced light elements such as hydrogen and helium. This idea explained why these elements in the universe today, these elements are so common in the universe today. His theories connected the birth of the universe with the chemical composition of matter, which is a central topic in modern cosmology and astrophysics. Another major influence of Gamow's work was the prediction of cosmic microwave background radiation. And his colleagues suggested that if the universe began hot, there should still be leftover heat in the form of radiation spread throughout space. When scientists discovered this radiation in 1965, it provided strong evidence for the Big Bang theory. Today, this radiation is one of the most important pieces of evidence in cosmology, and its study has led to detailed maps of the early universe. In astrophysics, Gamow's ideas help scientists understand how stars produce elements. He suggested that stars act like nuclear reactors, where lighter elements fuse to form heavier ones. This concept laid the foundation for stellar nucleosynthesis, which explains how stars create elements like carbon, oxygen, and iron. Modern astrophysics relies on these ideas to study star formation, stellar evolution, and the life cycle of galaxies. Gamow's work also influenced how scientists study galaxies and cosmic structures. By understanding how matter formed in the early universe, researchers can explain how galaxies, stars, and planets developed over billions of years. His theories provided a framework for studying the large scale structure of the universe and the distribution of matter in space. Beyond specific discoveries, Gamow changed how scientists think about the universe's origin. A showed that the universe has a history that can be studied scientifically. Instead of being a mystery beyond human understanding, the origin of the universe became a subject of mathematical models, experiments, a subject of mathematical models, experiments. This shift is one of the greatest achievements of modern science. In conclusion, George Gamow's work deeply influenced modern cosmology and astrophysics. He helped explain in how the universe began, how matter formed, and how cosmic structures evolved. His ideas laid the foundation for our current understanding of the universe's origin and continue to guide scientific research today.